Good afternoon everyone, my name is Douglas Bell. I'm the BIM lead at IES. So today we're going to have a look at the future of BIM from an IES perspective and the way we see it progressing to in the future. We'll have a quick BIM overview followed by how you can integrate building performance and building information together, which is one of the key things that we're looking to achieve here. We'll have a quick process recap and a demonstration, and then we'll look at common issues and any updates and helpful tips that we can pass off onto yourselves so that you have a much smoother process. Okay, so at the moment basically BIM level 2 is trying to change the building industry to go from analog processes to digital, and we're looking to have no data drop-offs, which has been pretty common in the industry up until now. So looking at just in this process, again with BIM level 2, we're really basically only looking at a single asset. But even at the moment with a single building asset, you can still glean a lot of information, even if you don't have any geometry. All these graphs that you can see in front of you are just climate data and matrix that you can take out of the virtual environment very early stage. As I say, no geometry required for this information, just a site location. That is all you would need. So moving on from there, if the way that we would look to see the future, so you, instead of looking just at the asset in an isolated situation, we could maybe look at the asset at a master planning level. So you could start to take into consideration how far, let's say for an office building, how far is it from all the transport links, or maybe what's the nearest shops that are available if you're putting an office in a certain location within a certain district of a city. So that would be a district level. So then to take it from there up a level again, we'd maybe look at the city level. So instead of looking at a single area of a large city network, a large city area, you would actually look at the whole city and look at the building performance and the embodied carbon within that as a whole. So that would be where we would see the BIM going in the future, being able to access different levels of data, different levels of granularity whether it be a single asset or multiple assets. So I'm sure you've majority of you have seen this extract out of the PAS 1192 Part 2. So it's just showing you that the quick overview of it, as I say, would be you've got your central area here, which is governed by the BS 1192 2007, which is basically your common data environment, and this is the standard methods and procedures for taking a design from brief stage right through to an operation. You've then got the information delivery cycle in blue that surrounds this, and this is what you would the past papers are PAS 1192 Part 2, PAS 1192 Part 3, and some other various documents, PAS 1192 Part 4. All these documents go together along with the BIM protocol and the government soft landings to make up a set of standards, methods and procedures that allow you to deliver information with no data drop-offs from the very early briefing stage right through to an operation. So that's a small, very brief overview of the BIM process and some of the documentation. Now again, this is another graph that you've probably seen quite a lot, and the only reason I want to bring it out again today is to highlight where the position is for building performance within the building information modelling process, or the information modelling process as it should be. So you can see here we've got the blue line 1 is the ability for a team to impact the cost and the performance as you go through the project from early design phase right through into operation. The red line 2 is the design cost of making these changes as you go through the process, and you've got the black line with the hump in the middle, which is the design process, traditional design process, and then you've got the green workflow, green BIM workflow there, where you can see the humps move back, so it's where it's easier to impact on cost and performance at a lot less cost. From a building performance software, this is where it's best placed early on in the design, as you can get a lot of data gleaned from the design bit. As I've started off with, you don't need a lot of you don't need any geometry to start getting data out, and obviously you need to feed this back into the design process all the way through. So how can we do it? So, and how is BIM building information can relate to building performance? So here we've got an example. We've got a mass model for a building. We can export that. So the image you see at the top left is a Revit model. So it's been exported into the virtual environment, and you can quickly see some shadow analysis, some solar intensity analysis. Fairly early stage, just having a mass there. So we can take that design and move it to another level. We can start zoning up that mass and adding in a bit of glazing. And again, we can export that and start running some analysis within building performance software. Again, take it a step further. We can start putting in a bit more detail zoning. So we've got a core zoning there, and we've got a bit more curtain wall glazing, a bit more detail, and then we've got perimeter zoning, so we can start looking at daylight and maybe heating and cooling loads and actual overall energy performance of that building, until you get to the final detail stage with Part L, compliance, your EPCs. At this point you can see you've updated the model, you've actually got specific zones that have been allocated to the design. So we can take this on and again go and see if this building complies, and look at how it's going to perform in the future. So that's just a bit about how you can, again, these are models that have been built within Revit, and we've taken them into the virtual environment and run analysis on them, and it's fairly straightforward there. So I'll just come out of this and we'll have a quick demonstration of the process. So here we have a Revit model. It's got glazing on it, and we'll have a quick look at the ground floor. You can see here now, whether it's Revit Architecture or Revit MEP, the main thing that you have to do, one of the main things is you have to add in spaces or rooms depending on which one you're using. Obviously if you have got the full design suite, it doesn't matter which one you add. There are slight differences between the two, Revit and Architecture and Revit MEP, in that with Revit MEP you can actually add in some more detailed data to your model and export that to the virtual environment. Now, I am giving this demo using Revit, Autodesk Revit, but you can use any package that outputs an IFC file, a GBXML file. We can import that to the virtual environment. That's not an issue. So what we can do here, if I just select this space here, so I'm just going to update. So if you go down and if you're using Revit MEP, these are the additional options that you can set. So you can see, you can go in and change any electrical loads. These are all default, you can see here. If I just go into the occupancy gain, so it's changed off of the default, and what I'll do is I'll just change this, and I'll make it a silly large number. So I'll change the occupancy up there. You can go in and also change constructions, or look at the space types. You can change these to here, or maybe you look at changing the lighting schedule. change the profile within there. So any of that data that you change in your properties for a space, since we're using Revit MEP here, then that will export across to the virtual environment, not a problem. So if I've made that change, I'll click on save. So the other thing, because we're using, again, it's the same for whether you use spaces or rooms, you just need to check that the spaces and zones option, the area and volume has been set to include areas and volumes. That's key. You then, if we go to the add-ins tab, to the VE options, now because I want to extract the data from the Revit model here, there is a settings option within here, a tick box, which I'll just open up and show. Go to GBSVL, override MEP transfer. I've unticked that because I want the data out of the Revit model. So I'll just OK that. So I've got that. The other option you'll see maybe while it's in there is the complexity that I use. So there's the 5 options. Now these are mirrored as to the same export options that you have in the manual GBSVL export from Revit itself. So basically you would use it depending on what you're trying to achieve in your simulations. So if you're looking at solar shading devices on the outside of your building, you'd probably say simple shading surfaces. But if you're actually looking at doing a lighting design, or it was a final detail design, looking at part L, you maybe choose a complex with mullions and shading. So I'll just leave that at the most complex for now. So I've okayed that. Again, because I've made some changes, I've gone in there, click save. So at this point, you basically, the key thing you can see here as well before I press anything, I've made sure that I've got there's no air gaps within my model. I've got a space or a room placed everywhere in my model. But what we'll do, we'll just go quickly to a section view. And we'll just check that as well. So you can see there's no air gaps at all within the model. And that's one of the key things. If you have any areas that do have gaps within the model, then this will come out as external air, and you'll obviously get external constructions applied to these areas. So that's why your full building envelope has to be fully bound and closed. So I'll just go to import model. So that'll just run through. Down the bottom left hand corner you get a progress of information. And that'll just run through. So yeah, the main things you need to check, areas and volumes are on, and that you have placed a room or a space everywhere in your model, including risers and lift shafts, etc. You need to keep it simple and clean. The best way for creating walls is using wall centerline, and in addition it is best to use the basic, especially early on, use the basic concept walls, and don't use any compounded ceilings. Using a compounded ceiling instead of generic can cause the Revit GBXML issues, so if you keep it simple, it exports cleanly. Now you will get this, if you've used the plugin before, you've seen this BIM report, which basically looks at raw space boundaries before we've applied our algorithms, and then it shows you the work done by our algorithms in the background. And basically what we're trying to do is trying to achieve fully bounded closed volumes with the surfaces orientated in the right direction. These are the main kind of issues that we get trying to take geometry from other design tools to run analysis on. So the one main difference at this point is if you're using Revit architecture, you will get a properties dialog pop up, and it will have a preview image all in the model viewer that you can have a look at. That lets you look at the geometry early stage. Because I've used the MEP override transfer to unticked, we're basically taking it as it is. So what I'll do, I'll just click on launch the VE now, and we'll export to the virtual environment. So we can see our model here. I'm just going to flick into a front view, have a look at the geometry. I always like to have a check of the geometry once it comes in. So I'll just have a quick look at that in the model viewer, see how we're looking. It's always good to give it a quick visual check. So quite happy with that. At this stage you could quickly look at the shadows that you're looking at for your building, maybe run a quick see how it's performing. So close that off. So what I'll do, when we were in Revit MEP, we changed some of the settings. So just to show you that information, I'm just going to go into our Apache thermal simulation engine, and I'm just going to select this model. Now you can go into our tabular room data section, which will give you basically you get your general information, your templates, room names. You can see all the room names that come across. It'll give you room volumes, floor areas, etc. In there, but you've also got any room conditions, heating set points that you can go in and change. If any of that, you can check that information if it's something you've changed, and you can see you can quickly update quite a lot of information. But in the tabular room data area here, you can change that and update that information. Now, it's quite a lot. If you want to reduce it, you just select a single room and just open this up, and it'll just show you that single room, which I'll show you. So there you go, you can have one, look at one room in particular. Now that's obviously looking at the data listed out. You can also do this visually, so I'll just do that. So we changed our room conditions, and internal gains, and I'm going to look at occupancy. That was the one thing that we changed off default, so we're just going to display it as people. Need to select the whole model, it's much better. So I'll do that again. So we can see here in the Apache viewer, if we look at the information bar on the left hand side here, we can see that I changed the occupancy up to 500 people. We're quite busy in that office today, but it's a very easily using the Apache viewer tool. You can quickly see what data you've assigned or edited that's come across. So that's the Apache viewer. So that's the basics of exporting from Revit to the virtual environment. As I say, you can do this through any other package as long as it imports a GBXML or an IFC. Outputs a GBXML or IFC. You can bring it into the virtual environment. Not a problem. Now, the process that I've shown here is very linear now, and it's basically having your model in a design tool and then bringing that into the virtual environment analysis tool. Now, I won't touch on it just now. There are ways that you can link these up so that you can push data back and forward. Later on, Jean Carré, he'll go into a bit more detail on that process, and there are other ways of doing it, but this is just to give you a basic feel of how you export from another design tool into the virtual environment analysis tool. So if we just now go back to the PowerPoint, add our demo. So these images that we'll show here that are just basically common issues that we come across. One of the most common ones is the image in the top left here. You can see that the rooms have been placed into the geometry, but they actually don't meet up to the next floor or up to the ceiling level even. So there's big air gaps between the floors. So obviously you're basically going to have external air between each floor of the building. That's as I say, one of the most common issues. This image in the middle here, you can see and it's related to the image in the top right. It's basically where you've got the lift shafts added in, but there's the big opening to where the lifts would be. So the middle image is showing you where the room fill is. It's actually going right through all these areas. So you would need to have some way of closing the lift shafts off from that main circulation space, so that you get results for these two separate spaces. Another issue which will show, you can see here, is that there's riser spaces that haven't got any rooms placed within this model. So you're going to have big air gaps in the model, which we're not wanting. Again, another common issue here is areas and volumes aren't set, and I've highlighted this one in red here, and again there's one image in the right hand side, there's no rooms placed at all, but in red there's highlighted the partitions that are in the central areas of rooms, or protrude into the centre of rooms, that are set to room bounding. In that scenario, let's say we take the middle shot where you've got that kind of changing room area. You could either split that space up into 3 areas, or you would just take the decision, if we want it as just one big space, you'd have to select these partitions that are highlighted in red and make them non-room bounding. Otherwise you're going to get triangulation and quite messy geometry coming out at the other side. Because they'll be set to room bounding, they'll just interfere with the GBXML file and won't make that room come across cleanly. Again, some more of the same issues. The room's not placed. You can quickly throw a section through a model and see and just turn the room fill on, and you'll see where the gaps are within the model. I've highlighted in the centre here that one room and concentrated on the levels that it's tied to. One of the key things that you should do when you're placing rooms or spaces is add in levels to tie these two. And doing that, one of the advantages is if you do change your levels in your design at any point, all your rooms or spaces will move up and down with the levels that they're tied to. But it also makes sure that you've got no air gaps between each floor. We've made some updates in the latest releases. So before we were just allowed you to include whether you tidied up where there's columns are. Now that option does allow, is relying on that being written by the software we're receiving the GBXML from, written in the right format. So it needs to be, columns need to be called columns, so if they are, hopefully they'll be ignored if you want. If they're not, you just need to set them in the model to non-room bounding. Now we've added in a bit more detail to how basically the geometry comes across, where it says there attempt to fix shell or surface orientation. It did that automatically in the past, but now we're allowing you to turn it on and off if you wish. We've added in the user's ability to increase the number of edges as well as the number of surfaces in a space boundary. So it basically is trying to say, if you've got a bit of messy geometry with lots of edges and lots of surfaces, we'll tidy it up to the values that you put in there. Now if all else fails, we'll move on to option B, where we'll just throw all that geometry away. We'll take the floor plate and basically try and extrude a volume from the floor plate. And if that does not work, we'll just bring across what we see as shading devices. So you'll see, so if you open up your model and you see a lot of green surfaces that don't have closed off bound rooms, then it just means that it's not been in the GBXML defined in the geometry source from the likes of Revit or ArchiCAD or Bentley systems. So that concludes my presentation for this afternoon. Thank you very much.